Hello everyone. In this video given is a regular hexagon. A regular hexagon mean all the sides have same length and all the angles at the vertices are same. There is a sphere which has length equal to the length of this side length of this hexagon, and it is adjacent to one side of the uh, polygon. If we draw a line segment from point H to E and M is the midpoint of this line segment, and if we draw a line segment from point G which passes to this point M and meets the center of this hexagon, then by this limited data we have to find the value of angle FGM. Let's move towards the solution. Let we call the side length of this polygon as lowercase a. It means the length of all sides of this polygon and sphere have are equal to a. And we know that the sum of interior angle of a six-sided figure is 720 degree. So if we divide 720 by 6, then angle at each vertex is 120 degree. Now let we draw a rectangle QHRE in which HE is its diagonal and M is the midpoint of this rectangle. First we focus at point A. Since the angle RAF is of 90 degree and the total angle at this vertex is 120, so this remaining angle is of 30 degree, and vice versa at point E the angle QEF is of 30 degree. If we extend the line segment from R to B, then we have a right triangle BRA. So from this right triangle ARB, we have sine of 30 degree is equal to opposite side divided by its hypotenuse, means BR divided by AB. AB is the side of polygon. Uh, from here BR can be found as AB sine 30 degree. So AB length is equal to lowercase a and sine 30 is equal to 1 by 2, thus BR is equal to a by 2. Now we focus on this length RE. RE and HQ lengths are equal as they are parallel sides of a rectangle. So we can write it as RE is equal to this whole length BE minus this length RB. So RB is equal to a by 2 and BE is the twice of the side of polygon. So this is equal to 2a minus a by 2. So RE, that is equal to HQ, this is equal to 3a by 2. Now we focus on the length HR. This length HR, which is the other side of this rectangle. HR is equal to HA length plus AR. HA is lowercase a length and AR is AB times cos of 30 degree. And we know that cos of 30 degree is equal to square root of 3 by 2, that is equal to RH, that is equal to EQ, that is A plus A times square root of 3 by 2. Now we draw a line segment from point M to the N which is perpendicular to FG, which completes a right triangle GNM. Now if we draw the line segment from point P, which is perpendicular to the line segment QH, it divides GZ in two equal parts. Mean GZ is A by 2 and ZH is A by 2. And since point M is the center of this rectangle, so from here we can, if we extend this line segment from point M to some other point, then NM is equal to A minus HQ by 2. So HQ by 2, HQ value is equal to 3A by 2, so it is equal to A minus 3A by 4, and thus NM is equal to A by 4. This length is A by 4. Now we have to find the length GN. Again, this M point is the center of this rectangle, and if we complete this line segment from up to here, this divides the length of rectangle into two equal parts. Gn is equal to EQ by 2. EQ by 2, and so this is equal to A times 2 plus under root 3 over 4. We have substituted the value of EQ from here. Now we use tangent of theta in this triangle, and we can see that tangent of theta is equal to NM divided by GN. So these both values we have in form of A, we substitute them here, which will give this relation. A by 4 is present in numerator and denominator as well, so this will be cancelled out, and tangent of theta will be equal to 1 over 2 plus square root of 3, and theta will be tangent inverse of 1 over 2 plus square root of 3, and if we use calculator we will get theta is equal to 15 degree. That is the answer. Thank you for watching. If this video is helpful, then subscribe my channel for more such videos and give a like to this video. Thank you.